Welcome back, dear students. We are still on our measurements, and this is our lesson 2. And we're going to talk about right pyramids in this lesson. So brace yourselves. It's going to be an interesting one, this one. Right. So to start with, I'm going to talk about a right pyramid right here. I hope you are seeing this shape that I've got over there. So I want you to be able to understand what a right pyramid is. Well, unlike a prism, you are noticing that a right pyramid, it may have, in this situation, we are dealing with a square. This one right here is a square. It looks like a rectangle, but, well, it is a square this time around. But at the top, we don't have a square. It's now just an apex that we have at E right here. So this part here is there. It's not a square. So that is why we call these ones the right pyramids. So please notice the difference between the pyramids and the prisms just right away. So how is it that you calculate the area of the right pyramids? Still, you look at the shapes that made that a pyramid consists of, actually. So if we're talking about this particular one that we've got here, especially this one on the right-hand side, notice there is a square at the bottom, and if it is a square at the bottom, those things that you're seeing on the sides are actually triangles. In this situation, because this one right here is a square, it means that the triangles that you've got have got the same base, because this side and that side and this side and this side are the same. And as you can see, they form the bases of these triangles. So we have, in this situation, it means if I want to calculate the total surface area, I already want to do this, I'll have to calculate the area of a square plus the area of 4 triangles. In this situation, we are noticing that the areas of these 4 triangles are the same. So we can calculate them at the same time, really. If the area is not the same, you calculate them separately. All right, so we already know that the area of a square is side squared. And here, if we want to calculate the area of a triangle, we just have to say half base times height. So how do we go about this one? So we are going to go and say, since we were told that AB is 8 centimeters, that is AB, which is this distance right here, it means it's the distance, is the side of a square. It means everything, including this one, is also 8. So we're going to say 8 squared to start with for the square. Well, drawing a net diagram like what we did over here is helpful when you start, but of course you're not going to be able to afford to draw every net diagram for every shape we're going to have. So that is why you have to notice if it's a right pyramid, and this time around we call this one a square pyramid. So if you're dealing with a square pyramid, all that I'm saying here, for every other square pyramid, it will be true. Okay, so you will have to use this form of thinking for your square pyramid. All right, so it's 4 of those ones that are identical. So half the base of these triangles, we know that it is equal to 8. So it's already 8 here. But what about the height? Luckily for us, this time around, we were given the height of the triangles. So this height here, 12, was given to us as the height of the triangles, as FE. So you can see that FE is a slant height. Look at the diagram. So we are going to call this one the slant height. We normally represent it with the letter S. The slant height happens to be the height or the perpendicular height of the triangles. Remember, these triangles are actually slant as well. So the slant height in this situation happens to be 12. So you substitute 12 over there, and you get your answer for the total surface area of this first prism. So in these, did I say prism? Of this first pyramid, please, pyramid. So please notice when we're talking about pyramids, you have to see that pyramids have got their own height, their own perpendicular height. So if I go back there while you're using your calculator, do you see this distance from here at the center all the way to the top at E? That one right there is what will be called the perpendicular height of that prism. I keep saying prism, right? Of that pyramid. So you need to actually have that height if ever you want to calculate the volume of this pyramid. But if you want the surface area, what you need happens to be the slant height, the one in red right here. So please, people, now that you're done with your calculator work, you can tell me now what the total surface area of this thing you're getting there. If you're like me, you're getting 256. And since we are using centimeters here, if it's area, you still say square centimeters, like that. All right, perfect. Let's move on and let's see what else we have. I decided, let me give you another one where you can simply calculate the total surface area. As you can see, this one at the bottom is still a square, right? You're noticing that the sides are the same, 25 here and 25 over there as well. So you see there's a 25. So these lines here, they simply mean that it's a square. So we have yet another square pyramid. And in this square pyramid, again, do you see the height that was given to you? It is the slant height. It is the height of the triangles. It's not the height of the pyramid. Because if you wanted the height of the pyramid will come somewhere here. It will come right in the middle. And it will be 90 degrees to this surface right there. Not the one that we've got. So 22 centimeters here is the height of the triangles. So again, we have an easy situation because it is a square pyramid. You know that there is a square which you calculate by saying s squared, and you know that there are 4 identical triangles which you're going to calculate by saying half base times height. It's that simple. So the side of this square are 25 centimeters long. And let's see, these triangles have a base of 25. And we were given the height to be 22. There was nothing at all for us to really try to look for. Everything was really given to us at this point. And I hope you are now getting the confidence that I know that you're going to need as we carry on with this lesson. So if you have this and you do it correctly, you should get 1,725 like I am doing here, square centimeters. Easy peasy, easy peasy. Let's just go ahead and have another one. There is something I want you to see now as we are answering this. We are not always going to be given the slant height, just like what you will notice on this question over here. Notice that this time around, the height for the triangles, which is this one over here, is not given to us, this one right here. We need that distance so badly because that's the height of the triangles, the 4 triangles that we are dealing with. Luckily, it is still a square pyramid, okay? But we do not have the slant height, which is the height of the 4 triangles. So we have to calculate it first. So I needed for you to see that you may be asked that way. So to calculate this one, which I'm going to call the slant height, we will use Pythagoras theorem. And you see how we are going to use Pythagoras theorem? We extract that triangle. This time around, we were given 21.6 as the perpendicular height. You see, it's the perpendicular height and is the height of the pyramid, not the height of these slant triangles. So to get that one, let's first of all do Pythagoras. So we are going to first of all get my s squared, and I'm sure you're noticing that we have to say 17.7 squared using Pythagoras plus 21.6 squared. Well, let's get our s quickly. You just get the square root of that. You should find it easily. From what I'm gathering here, we should have, I'm going to round it off to 2 decimal places. It'll be some 27.93. Okay, let's have that one. And it does look like we are working in meters here. So we're going to also say it's meters. So that will be the slant height. Now that we have the slant height, we there is nothing that is going to stop us from getting what we want now. So I'm going to take this one down a little so we can get this one going. All right, let's calculate the total surface area then, which is question A. From what I said, if you have a square pyramid, it's your square, which is side squared, plus your 4 triangles, which you calculate by saying half base times height. I hope you still remember this. Your square plus your 4 triangles. It's very easy to pick up. So the square here has got a side, this base one. See, that's the square. It's a square that because those two sides are equal, and it's some 35.4 here meters. So you just make substitutions over there, and then you say 4, then I have half. What is the base of the triangles? Let's pick, for example, this triangle on this side. Notice that would be the base. Or let me just take this one, since we already know the slant height. That would be the base, which happens to be 35.4. And then we just finished calculating the height of these triangles. The height of these triangles will be this value that we've got over there. So that is 27.93. It's good to use the exact one, but I think this time around I'm just rounding off a few things. So let us see if our calculator will be faithful to us and that we can get our answer fast here. Well, it is 3,230.60. I'm going to write it like that. So I hope you're getting the same one. If not, you can always give me a comment or something like that. Okay, thank you very much. Let's quickly see what's what here. That is what you do with this one. So let's look at this one, B. You're supposed to calculate the volume of a pyramid. I know we haven't done our volume yet, but some of you remember this because it's assumed knowledge. If you want to calculate the volume of a pyramid, it's just 1/3 of that of a prism. We have a full lesson on this one. I will make sure that you have this one. So I'm just going to write it down because the question is already here. Other than that, I was going to leave this question out. So if you know what I'm doing, good for you. So you say 1/3 the area of a prism. So length, breadth, in this situation, the length and the breadth are exactly the same, which means it's 35.4 and 35.4. It's a square. But the height of this pyramid, this is the time when you use the perpendicular height, the 21.6. I hope you still know where it is. This one right here. So this 21.6, the perpendicular height, it's used when you're calculating volume of a pyramid. And if it's total surface area, we just use the slant height. So keep that in mind. Well, if you do this correctly, you should get 9,022.75 square meters. Okay, so that could be your correct, rather cubic. You see, this is volume, right? If we are talking about volume, you will notice in our third lesson that this one will be cubed like that. Okay, perfect. Now that I've done all these ones, why don't you pause and answer this one right here, this question right here, your number 1 question that you're doing yourself. Why don't you answer this one? It's still a square pyramid. I would like to see if you can calculate the total surface area. Pause and answer. Thank you if you got that one right. So I'm sure you still say it's side squared because you notice it's a square pyramid. It's a square, this one. So the moment it's a square, you know that your 4 triangles have got the same area, so you calculate the area at the same time, half base times height. I hope you got this one right. So you have your 14 squared there, and then let's see your base. Let's see if you have it. Do you have a base? Well, it does look like you do, which is 14. But you do not have the height, people. You don't have the height. You happen to have the perpendicular height, which is the height of this pyramid. You want the slant height. what I said, maybe I should go back and say it. I just remember that I didn't say it to you. This is the triangle that you need right here. That's the triangle you're going to use. But there is something you should learn about that triangle. Let's go back to this question so I can show you. Right. I want you now to take your calculator and see something. Do you see that the side CD, this is C, this side here is 35.4? Right? This part here, which is 17.7, this side here, is exactly a half of this side that we are talking about, CD. So if you would like that side inside this GF, make sure you just half CD. That is all you have to do to get that side inside. You can see why, because it's a square, or even if it was a rectangle, you were going to do exactly that. So make it a point that you do that even in all the ones that are coming. So even if your triangle is on the other side, like you will see in the next example. So let's go ahead and do what I asked us to do. So we know that from this point here to F, this distance right here should be half of CD if you were listening. So this part should be 7. And then that part was given to us as 16. So now we would like to try and find that slant height. I don't think we'll have a problem at all. So let's get it. Slant height squared is equal to 7 squared plus that's 16 squared. So these are centimeters, okay? So we want to say centimeters as well there. So let's just go straight to your slant height on your calculator. Okay, I have some square root of some 305. I think I'm going to keep it as a square root of 305. I feel better that way, but if you are feeling uncomfortable, you can write it as 17.46 like this. Okay, now that we have that one there, so we now have to substitute it. We needed that height. We needed this one. It's actually the height, the slant height is the height of the triangles. It's actually this one here. So now that we have it, we now know the height of the triangles. So the base will be 14 if you look at the triangle, and the height will just be that one right there, which we just calculated. Those two are at 90 degrees to each other. So you say half base times height. So it's half of 14 by the height, which we are going to put as the square root of 305. You know, we want to try and be as accurate as possible. So you use the whole answer if you would like to be accurate. Well, I'm getting some 684.9989775. So if you round it off, you can safely say we have 685 here. 685 square centimeters as our area. So I think this is, you now know how to handle a square pyramid. What about a rectangular pyramid? You know, something of this sort. So this right here is a rectangular pyramid. You can see at this point that the length, which is AB, is not the same as the breadth in this situation. So this is a rectangular. The bottom shape is a rectangle. And you can see it's a pyramid because it has an apex there at D. So at this point, when you're calculating the total surface area, you want to be careful. How so? Please notice, you still have to calculate in this situation the area of the rectangle, right? Let's write it down. So if you want to calculate the total surface area, you know that there is a rectangle. Well, good for you. That's the bottom part. Well, what else is there? Please, there are these triangles here. The triangles are no longer the same, unfortunately. Look at this triangle that I'm highlighting here. it is only the same, it has the same area as that one on the other side, this one. So they will have the same area, those two. So now you will have 2 times those triangles that I highlighted green. Well, the 2 that are not highlighted green, let me try highlight them red. Maybe you will see, but these lines are actually almost the same. That triangle and this one over here, over there, those ones are the ones that will have the same area. So you have 2 of those triangles. So now you have to be careful, you see. You have to be very careful when you calculate now, because your total surface area, you will say length times breadth for this first one. But when you calculate the area of these things, you have to notice that you will have 2 different types of bases and heights. So you have the first one, and then you will have the second one. So a second set of base and heights. So don't mix it up. Just know which base works with which height. That's all. You have to be extra careful on this one. Well, before I come and substitute into our formula, I'm going to leave it here for a while. In fact, for quite a long time, because here the slant height has to be calculated first. We are going to try and work on that. So for us to start all over, I'm going to erase everything that I highlighted so we can start again. People, if ever we want to calculate the total surface area of this, we will desperately need the slant heights. So at this point, there is DG. Do you see where DG is? That one is a slant height. We were not given. Is the height of these triangles, these 2 triangles that I talked about, DBC and DAH. Those 2 triangles, that is their height right there. So we would like to calculate that height. Let's just call that one, which one should I call which? So let's call that one H2, So if I want to calculate H2, notice I can use the perpendicular height, it's the one you always use, and then you have to use this side. Well, because you're using this side, it should be a half of this side. Please keep that in mind. That's the skill you need right there. You want FG, you won't have FG, but you have AB. Because this is a rectangle, these sides are already parallel, and there is a 90 degree over here. There are a lot of things to think of, but just know that this FG will be a half of AB. So what is a half then of 96? Well, I think you're noticing how that is going to be 48 here. Okay, so we have 48 over there. And then we already have 20 given to us here. Calculating H2 is going to be child's play. So let's go ahead and calculate H2. So H2, from where we are, H2 squared is going to be equal to, make sure that you just square those 2. It's 20 squared and 48 squared, isn't it? So 20 squared plus 48 squared. I would like to let you see, okay, the squared is not writing there. So our H2, use your calculators while there. If you say 20 squared and 48 squared, you should get some square root of 2,704, which will just be 52 units. So here we don't have anything, so we're just going to call that units. So that's what we are dealing with here. So now we have that slant height, H2. So if we're saying that's the slant height that we have, do you see that that slant height will work with a base of 42? So let's go and substitute that before we even forget. So come here. I'm going to say plus 2. I'm substituting the base and height before we forget which ones work together. The base of 42 works with the height that we just calculated now, which was 52. So now at least I know the area of these 2 triangles. Well, if maybe you're wondering, we already have the length and the breadth this side of the rectangle, I can put it 96 times 42. That's easy to see. Now we are with these ones in the middle. So it's plus these ones that we are going to work with now. So for you to understand how we are going to work, I am going to extract yet another triangle. So for you to see clearly, I'll have to erase everything on the board that I highlighted. I hope you'll keep that one in mind. Maybe you have two that you're highlighting on your own. So for the purpose of explaining, I'll do this. Now, I would like to get the heights of the other triangles. That would be this height here that is not highlighted. It's this height from D all the way to E. That's the one I'm looking for. Well, if I'm looking for that height, please people, I will have to use this triangle here. You always have to work with the perpendicular height and then half of something. In this situation, you have to go half of BC. So what the triangle you've got has got 20 over there. It's already there. And then you want half of BC. I think you understand why. Now half of BC would just be 21. And now you would like to calculate this one, which we are going to call H1 right there. So to get H1 squared from where we are, it should be 21 squared plus 20 squared. Okay? So get the answer of that and then get the square root of that as well so we can see what our H1 is. Well, from what I have here, it's square root of 841, which is just 29 units. Perfect. So you're noticing that we just finished calculating H1, which is this one, the height of these triangles here. So if we're saying this is the height, it means we have to use this as the base of the triangles, so that here there will be a 90 degree. So the base which works with this height of 29 is 96. So let's go and substitute 2 half the base of 96 multiplied by the height we just finished calculating now, which is 29. It is not necessarily too simple to do that. You just have to really concentrate and make sure you're not making mistakes in the process. Well, I would usually go straight to the answer, but for the love of it, let's go slowly now. Well, this should be some 4,032, right? I'm getting that. The 2's will cancel here, so it's 96 times 29. That should be some 2784 here. Okay, and then the 2's cancel again, so you have 42 times 52, which is again 2184. So it does look like I'm getting my total surface area of 9,000. That's an interesting value. Good. So I hope you also understood how we got to this. Please, please, please. So maybe you're wondering, why were we given that 20? Is the perpendicular height this 20 right here? This one. That's the perpendicular height. That's the height of the pyramid itself. Like I've already indicated, it's used for volume. So if you wanted to calculate volume of these, you will notice that after some time that the volume of a right pyramid, including this one, let me just do it since I mentioned it, you just say 1/3 the volume of the corresponding prism. You know, this is a rectangular pyramid. So if it was the rectangular prism, you're going to say length times breadth times height, right? So here you just have to say 1/3 length times breadth times height. As simple as that. So you just go and our length, do we still remember it? It was 96, right? Good. So it's 96. And then our breadth, what was it? Is it this 40? Yeah, it should be that 42 that is over here. And then our height must be that 20 that we were talking about. So that's the perpendicular height right there. So let's put 20 here. All right, so you can see I'm almost done with this volume. So the volume of this one, if we were asked to calculate it in any way, we were going to get it as 26,880. And these will be cubic units right here. Whatever unit you've got, to the power of 3. So you see, these are so far the pyramids that we have talked about. The square pyramid, we have the rectangular pyramid. Now, there is something else that looks like a pyramid. It has a circle at the bottom and an apex, and that would be a cone, people. So let's talk about a cone for a second. Notice it qualifies to be here because it has a circle right here at the bottom. You're noticing there is a circle. So to calculate the area of a circle, definitely you'll say pi r squared. And here on top, it's not a circle, so it doesn't qualify as a prism anymore. It has got an apex, so it qualifies as a pyramid. Now, to calculate the total surface area of this darling here, you just have to calculate the area of a circle, which I've already said it's pi r squared. And then for the curved part, which is this whole part right here, this curved part, this area right here, the whole area around, you calculate it by saying pi rs, which is this one, where s happens to be the slant height. You are noticing where it is, right? So that's your s. We call that one the slant height. I think you're noticing now that when we are calculating the total surface area in this situation, we are always using the slant height. However, next time when we calculate volume, you will see that we will have a perpendicular height somewhat in the middle like this, coming all the way to here. That will be the height, the perpendicular height of this cone. It is used only when we are calculating volume. Well, and perhaps if we are doing Pythagoras to get the slant height, if we have that, we can always do it that way. So you're seeing how this is simple, right? So let's go ahead and have use this formula on an example. It's always interesting to use an example. So now that we know the formula of calculating the total surface area of a cone, if we've got this one here on A, are we able to calculate the area of such a shape? Well, I'm not going to stress here. I'll just go and say the total surface area is equal to pi rs squared, which is for the circle, and then pi rs, which is for the curved part. You have to know which one is for which, because at times these shapes become hollow. It means that this one won't be there anymore. So if the circle is not there, you have to remove the pi r squared part. It has to go away. But in this situation, let's calculate it as if everything was there. Well, pi, our radius is 5.4. Just check if our units are correct. And it does look like everything is here. Our radius is still 5.4. We have everything. Everything was dished to us. And then we have 8.2 over here. So we were easily going to calculate this one like this. If we were asked to calculate the area of a cone. A very simple procedure, if you ask me. Well, it's just 230 here. 230.72 square centimeters, like that. So that is precisely how you were going to actually get that area. Well, you see, I want you to be able to do it even if it is. What happens if the question says that it was hollow, meaning that that circle was not there? So if it was hollow, the total surface area, if you were told it was a hollow shape, that's what I'm saying, in case you're not quite understanding what I'm saying. So you just you take the curved part only. You remove the circle. So you just say pi rs. In this situation, it's just a matter of saying pi, and it's 5.4 here, and then you put your slant height, which was given to you as 8.2. So it's a very simple task to change, to adjust your formula so it can suit your needs. 139.11 will be our solution for this. Okay, answer this bottom one. and see if you understood what I just said. Okay, thank you for trying it. As you are seeing, we were still given the slant height. Notice the slant height here is 7 centimeters. We were given, however, the perpendicular height. For total surface area, we don't even need it at all. We were not given our acute radius here. We don't seem to have it. So we're going to have to put 7 here and use Pythagoras theorem in this situation. So I hope you are agreeing with me when I say r squared. Oh, if I do that, you're going to think that I mean r of the radius. So let me do it again. Let me say r for the radius. R squared then is 7 squared minus root of 33 squared. I took a shortcut there. I hope you don't mind. Okay, so what will be our radius in this situation? Well, I'm getting 16 for r squared, so it's plus or minus 4. We will take the positive 4. So in this situation, we can see that the radius of this is 4 centimeters. Okay, so now that we have the radius, calculating the total surface area is going to be a lot of fun. Because if I say it's the whole cone, it means you say the circle plus the curved part, and then the circle has got a radius of 4 from what we just gathered. And then the slant height was given to us as 7. So we can easily, very easily calculate these things. So let's go ahead and use our calculators to get that solution. Should be 44 pi, right? 44 pi, let's write it to 2 decimal places, 138.23. We are working with square centimeters, so let's put that one in. Okay, so it's that simple, you see. It's something that you can easily do. And just to reinforce the fact that it may be hollow, if you are told it's open somewhat here, or maybe it's sitting on top of something, then you won't have to calculate this bottom part. So you will just have to say pi rs. So you have to listen to each question. So each question will give you its own conditions, and you just have to be careful. So it's a 28 here, right? 4 times 7. So 28 pi will be some 87.96. Okay, I'm saying if you were told it was a hollow shape, this is what you are going to do. Okay, so those are the pyramids we are interested in at this level. The cone, the square pyramid, and of course the rectangular pyramid. Well, you will get a triangular pyramid in one of my examples, just so you can have practice, but we hardly get that one at this level. But we will get some when we do the questions in our next video. So let's go ahead and finish off this lesson. I thought it would be fair to talk about a sphere, you know. It is not very good to just leave a sphere out of everything. It's a very simple thing to do, but here it is. Let me remind you, a sphere, it is not a pyramid, so let's just do it anyway. So if you have a sphere such as this one, you can see that the formula for the area of a sphere is already here, 4 pi r squared, just as easy as that. So if I were to just say, well, there is a sphere of radius of 5, I can easily calculate the area by saying 4 pi r squared, and I can make my substitutions and say 4 pi by 5 squared. You really just have to know the radius. Find the radius, and you will have your area. 100 pi, what's 100 pi? So that would be some 314.16, isn't it? So whatever this was, if I had such a sphere, that would be so simple like that. So notice at this point, a sphere, there is nothing we can do to a sphere to make it more interesting. Maybe we can try cut it in half so we can have what we call a hemisphere, like what I have here at the bottom. So a hemisphere is just half of a sphere. So if it's a hollow, 1, you just say half of this formula. So if it's hollow, what we are saying is that this part here is not there. The circle is not there. If it's a hollow shape, okay, the area of a hemisphere will simply be calculated by saying 2 pi r squared. You just half that one of a sphere. Well, if it is this one that I am seeing here, it has a radius of 3. Do you see that? So I'll just put it in. It's 3 meters. So when I substitute it in here, I'll say 2 pi and say 3 squared. What will you get for the area of this hollow hemisphere? Well, this is 18 pi, but it's better to put it to 2 decimal places for the love of caps here. So it's 56.55 square meters, like this. But many a times you will see that it will be a solid sphere. If it's a solid sphere, let's say it was a wooden sphere, when you cut it in half, even this part will still be there, you know. It will still be there for you to calculate the area thereof. So in that situation, that type of a hemisphere, when it's a solid one, or maybe you are asked to wrap this thing here, you have to include this surface that I highlighted in blue. So your total surface area will now be this 2 pi r squared plus 1 pi r squared for a circle. So it will be 3 of them. So it will be 3 pi r squared. Please keep that in mind. It's something that you can use whenever the situation arises. So if the circle is there, you use this formula. If the circle is unavailable, you use this first one for hollow. Okay, so our solution here will be 27 pi. So 27 pi is a very simple answer. That would be 84.82. And these are meters. So please, people, that is what we had time for this lesson. So let's go ahead and go to our next lesson and finish this. Thank you very much for watching this video. Don't be naughty now. You should now subscribe.